Okay, welcome students to a quick lesson on simplifying roots that are not perfect square roots. So, if you'll remember yesterday, I filmed it yesterday, but hopefully you watched it today, we went over the basics of perfect square roots, and we said perfect square roots are things like the square root of 9. And we defined a perfect square root as a root in which you know that there is one whole number you can multiply by itself to get that number. So this is saying, what whole number can you multiply by itself twice to get 9? And we know that's 3, right? Square root of 9 is 3. And we know that because 3 squared is equal to 9. We know that. That is true. Now, we said, on the other hand, something like the square root of 36 is also a perfect square because there is one whole number you can multiply by itself to get 36, and that is, of course, 6, because 6 times 6 is 36. Now, today's going to focus on non-perfect square roots, meaning we're going to be asked to take the square root of numbers that don't have a perfect whole number that you multiply by itself, right? So let's clear this out and do another one. Hope you guys like my new tool. I'm figuring out how to really do some of this stuff a little bit better. But let's imagine instead you were asked to find the square root of 20. Find the square root of 20. Now you might be saying, hey, that seems kind of hard. There isn't a perfect whole number. And that is true. So what you do is you start by breaking down the number under the radical sign. Remember, this little sign here, this guy, that's called a radical sign. It's called the radical sign. Let's get rid of that. Okay, so you start by breaking down that number into, say, prime factorization is what you really want to do. And if you remember, prime factorization is the process of breaking down a number into its prime factors, right? And prime being the only factors for that number, whole number factors are 1 and that number itself, right? So you're breaking it down. So you say, okay, how do you break down 20? Well, hopefully your mind goes first to 4 times 5, right? 4 times 5. Those are 2 of the prime factors of 20. Or sorry, not prime factors. Those are 2 factors you can multiply to get 20. Then you ask yourself, of these 2 numbers, are either of them prime? Well, 5 is prime because the only 2 whole numbers you can multiply to get 5 are 1 and 5. So 5 is prime. That's done. 4 is not prime, right? We can break that down one more time into 2 times 2, correct? That is correct. Okay, so we have now broken the square root of 20 into 2 times 2 times 5. That's 20. So that means that the square root of 20 is actually equal to the square root of 2 times 2 times 5. Of course, this should make sense. Now, you take 2 times 2 times 5 and you say, okay, well, is there anything that appears there twice? Yeah, 2 and 2 are in there twice, right? Because that's the square root of 4. So what you can do is you can say, okay, 2 times 2, here's a squared right here, right? 2 times 2 is the same as 2 squared. So the square root of 2 squared is saying the square root of 4, which is 2. So you can take that 2 out. And that would be equal to 2 times the square root of 5. And that is the square root of 20. 2 times the square root of 5 is the square root of 20. Now that might have been a little bit confusing, so we're going to do another one, don't worry. But if you need to write this down, pause it and get that work written down. This is one of the advantages of doing this online versus in class when all you guys would have to hurry to write down everything I wrote on the board. And let me clear it out, and we'll do another one. Okay, so let's say instead you had something like the square root of 12. The square root of 12. Okay. As you'll notice, this is also a non-perfect square. It's also a non-perfect square. So what you do is you break it down into prime factors, or really into two other factors. Sometimes it doesn't have to be prime factors, as I'll show you right here. Sometimes you can break it down, and you can sometimes breaking it down into non-prime factors can actually make it a little more clear. So we can break down the square root of 12 into that equals the square root of, let's say, 4 times 3, right? The square root of 4 times 3. The square root of 4 times 3. Now, one fast way is to remember exponent properties. Remember that? Those exponent properties where we actually said that, well, using those exponent properties for radicals, we know that the square root of 12 is equal to the square root of 4 times 3, but that is also equal to the square root of 4 times the square root of 3. These are the same thing, right? You see how they look different? It's the same thing. Now, the square root of 4 times the square root of 3, ask yourself this, is one of those numbers a perfect square? Well, yes, it is. I'm happy that you realized it. Square root of 4. 4 is a perfect square, right? Because there's a whole number you can multiply by itself to get 4. And what's that number? It's 2, right? So the square root of 4 times the square root of 3. The square root of 4 is 2. We know that. So we write just 2 outside of the radical sign. And then 2 times the square root of 3. We do not know the whole, I mean, we don't off the top of our head know the value of the square root of 3. Now we could find it out by doing a quick calculator, and I'll do that on my computer real fast. Let me find out what the square root of 3 is. Open up my calculator. It's not going to show up on your screen. But, you know, I'm just going to estimate right now on the top of my head. I'd say that the square root of 3 is, I don't know, 1 point something. It's definitely 1 point something. It's taking a second to load up. All right, let's see. I now have my calculator loaded up. You can't see it, but I promise I have it. And let's say the square root of 3. 1.73 is rounded. And then if you wanted 2 times the square root of 3, you'd say multiply by 2. So if you really wanted a decimal answer, which I don't want you doing right now, I want you to keep it in this form. But if you really wanted a decimal answer, you could say that 2 times the square root of 3 simplifies to 3.46, just so you know. All right, let's do one more. Still always got to have my coffee. All right, let's do one more. Let me clear this out. Let's say the square root of 45. If I told you, find me the square root of 45. Take a second, pause the video, try and do it yourself. Okay, did you get it? Let's find out. I hope you did. So start by asking yourself, okay, what are 2 numbers you can multiply to get 45? Now you can start at 45 times 1, but that's going to take forever. Just skip to 1, especially if a perfect square comes into your head as one of the factors of 45. That is how you know you're getting there quickly. And fortunately for me, I do know one of the factors of 45 is a perfect square, and that factor is 9. And what do you multiply 9 by to get 45? You multiply 9 by 5. The square root of 45 is equal to the square root of 9 times 5. The square root of 9 times 5. Remember, now you can break them up into their own square roots. So the square root of 9 times 5 is equal to the square root of 9 times the square root of 5. Square root of 9 times the square root of 5. Now look at these. If you didn't get it earlier, try and figure it out now. Can you break down one of these? Is one of these a perfect square? Yes, it is. 9 is a perfect square. The square root of 9 is 3 because 3 times 3 is 9. 3 squared is 9, square root of 9 is 3. Hopefully you can see that relationship go back and forth, back and forth. So you can break down the square root of 9, and that becomes 3. So this is equal to 3 times the square root of 5. And that would be your final answer. Now, let me know if you have any questions through email. That's the easiest way, or leaving a comment on Google Classroom. This will be accompanied by just a quick question I want you to do. But ultimately, make sure and keep your eyes posted on Google Classroom for the cumulative task that is coming up. All right, guys, have a good day. I'll see you later.